Okay, this problem requires a little bit of algebra. Starting off here, this one mass is going to compress at a distance of x1. And so this really is mass 1 times g is equal to, which is the gravity down, is equal to the spring force, which is going up, which is k times x, and k times x1. And the second one, it's as if there's two masses going down and almost like there's two forces going up. It's going to derive to something along these lines, but let me show you on the back what happens here. And so we start over here with this question. This is what we said before. The upward force is k times x1. The downward force is m1 times g. These are equal because it's at equilibrium. And we can run it like this: kx1 equals m1g. We can rearrange it to solve for k, because later we're gonna plug it in over here, and we'll get to that in a second. This one is a scenario where there's two masses on it, and so it's almost like there's two forces down, m1g and m2g. We can use a distributed property and distribute that out, and m1 plus m2 is both masses are pushing down times g. G is the same. K is the same in each case. This is almost like there's two springs pushing up. There's not really two springs pushing up. It's one spring K, and it's pushing both distances x1 and x2. This is kind of just a way to look at it, like there's two up and two down. These are equal as well. It's equilibrium, so the two up and the two down are equal. So that means that the two masses down times gravity are going to be equal to the two distances compressed times k. And so this is our basically our basic equation for scenario 2, and this is our basic equation for scenario 1. So when you put this one together with this one, you combine them and you put this k in for this k, and that's the combination of the two equations here. And so that's really solving the equation. How do we get to our final answer is a little bit of an algebraic trick. So it looks weird, but you take mg over x1 times x1 and you distribute it in times x2, and you get these two expressions. As soon as you get those two expressions, the x1 over the x1 cancels. This m1g actually cancels that x1 m1g. And so it immediately leads to a lot of cancellations. And then right here, we rearrange. m2g is equal to m1g x2 over x1. And as soon as you do that, you can see that the g's cancel, and you're left with m2 equals m1 times x2 over x1. And you can rearrange to solve for x2, since that's the way we want it. We want it to solve for x2. If you solve for x2, you get x1 times m2 over m1. And that's actually the final answer in the series of the quizzes there. So that one's actually a little bit of trick, so hopefully that helps you out.